On July 23, 2015, NASA made headlines worldwide with the announcement of Kepler-452b, an exoplanet detected by the Kepler Space Telescope. Situated approximately 1,400 light-years away in the constellation Cygnus, this distant world quickly captured the public's imagination as one of the most Earth-like planets discovered at the time. What set Kepler-452b apart was not just its size or location, but a combination of factors that suggested it could potentially harbor life. Its orbital period of 385 days, only slightly longer than Earth's 365 days, meant it experienced seasons in a rhythm familiar to us. Orbiting a star remarkably similar to our Sun, it receives about 10% more energy, leading to an estimated average surface temperature of around 80 degrees Fahrenheit, 27 degrees Celsius. This places it firmly in the habitable zone, where liquid water could exist on the surface, a key prerequisite for life as we understand it. The discovery was part of the Kepler mission's broader goal, to survey a portion of the Milky Way for Earth-sized planets in habitable zones. Launched in 2009, the telescope used the transit method to spot these worlds. This technique involves monitoring stars for periodic dips in brightness, which occur when a planet passes in front of its host star from our line of sight. The depth of the dimming reveals the planet's size relative to the star, while the frequency indicates its orbital period. For Kepler-452b, these transits were faint but consistent, confirming a radius about 1.6 times that of Earth, classifying it as a super-Earth. Complementing the transit method is the radial velocity approach, which measures a star's subtle wobble caused by a planet's gravitational tug. This Doppler shift in the star's light spectrum helps estimate the planet's mass, roughly 5 times Earth's for Kepler-452b, though exact figures remain approximate due to observational limits. These methods revolutionized exoplanet hunting. Before Kepler, astronomers relied heavily on ground-based telescopes, which struggled with atmospheric interference. Space-based observatories like Kepler eliminated that noise, leading to the confirmation of over 2,600 exoplanets during its primary mission. The radial velocity method, pioneered in the 1990s, excels at detecting massive planets like hot Jupiters, but it's less sensitive to smaller, rocky worlds. The transit method fills that gap, though it requires precise alignment. Only about 1% of exoplanets transit from our perspective. Together, they've painted a picture of a galaxy teeming with diversity, from lava worlds to ocean planets. To quantify habitability, scientists developed the Earth Similarity Index, ESI, a scale from 0 to 1, where Earth scores 1. Kepler-452b's ESI of 0.83 ranks it among the top candidates, surpassing many others like Kepler-62f, 0.69, or TRAPPIST-1e, 0.77. The announcement ignited global excitement. Media outlets dubbed it Earth 2.0, fueling discussions on social media and in classrooms. It came at a time when climate change debates were intensifying, prompting reflections on whether humanity might one day need a backup planet. Scientists like John Jenkins, a Kepler data analyst, emphasized its age. The host star, Kepler-452, is 6 billion years old, 1.5 billion years older than the Sun. This implies Kepler-452b has had more time for life to evolve, perhaps even intelligent civilizations. If Earth took 4.5 billion years to develop complex life, what might an extra 1.5 billion yield? Speculation ranged from microbial mats to advanced societies, though NASA cautioned that habitability doesn't equal inhabited. Yet this hope was tempered by realities. Being in the habitable zone is no guarantee. Venus, after all, sits in our Sun's habitable zone, but is a hellish greenhouse. Factors like atmosphere composition, magnetic fields, and plate tectonics play crucial roles. Kepler-452b's discovery spurred advancements in follow-up observations. Instruments like the James Webb Space Telescope, JWST, launched in 2021, have since analyzed similar exoplanets' atmospheres for biosignatures, gases like oxygen or methane that could indicate life. While Kepler-452b is too distant for detailed JWST study, its light is too faint. It inspired missions like Plato, planned for 2026, to target closer analogs. In retrospect, Kepler-452b's reveal marked a shift in astrobiology. It moved the field from mere detection to characterization, asking not just, are there planets, but could they support life? This has led to interdisciplinary collaborations, blending astronomy with biology and geology. For instance, models now simulate how super-Earth's stronger gravity might compress mantles, affecting volcanism and carbon cycles. The initial hopes weren't naive. They were a catalyst for deeper inquiry, reminding us that each discovery peels back layers of the universe's mysteries. As we ponder Kepler-452b, we're not just looking outward. We're glimpsing possibilities that redefine our cosmic solitude. You're hurtling through the void of space, leaving behind the familiar glow of our sun, racing toward a distant beacon, 1,400 light-years away. There, in the constellation Cygnus, burns Kepler-452, a star that whispers secrets of cosmic kinship. This isn't just any star. It's a near twin to our own, a G2-type yellow dwarf, slightly larger at about 1.11 times the Sun's diameter, yet radiating with the same steady, life-affirming warmth. But here's the twist that sends chills down the spine of astronomers. Kepler-452 is ancient, clocking in at 6 billion years old, a full 1.5 billion years senior to our Sun. Think about it. What tales could this elder star tell? In the grand theater of the universe, where stars flare and fade like fleeting fireworks, Kepler-452 stands as a pillar of stability. Unlike the temperamental red dwarfs that lash out with solar flares capable of stripping atmospheres bare, this star hums with quiet reliability. No violent outbursts, no deadly X-ray storms. Instead, it offers a serene canvas for life to paint its masterpieces over eons. Now, zoom in closer, drawn by an invisible gravitational thread. to the world that dances around this cosmic elder, Kepler-452b. Its orbit? A near-perfect echo of Earth's, stretching 385 days long, positioning it at just the right distance, about 1.05 astronomical units from its star. Not too close to boil away in infernal heat, not too far to shiver in eternal frost. This is the Goldilocks zone personified, where temperatures hover around a balmy 80 degrees Fahrenheit on average. But wait, receiving 10% more stellar energy than Earth, that subtle excess could be the spark of drama, teetering on the edge of paradise or peril. Yet for now, let's revel in the promise, free from the curse of tidal locking that dooms so many exoplanets to Jekyll and Hyde existences. One side a blazing inferno, the other a frozen abyss. Kepler-452b rotates freely. Heat circulates like a gentle global breath, fostering equilibrium. No scorching daysides or icy nightsides here. Instead, a world primed for balance, where dawn and dusk paint the skies in hues we can only dream of. Delve deeper, past the orbital ballet, into the planet's very bones. Kepler-452b bulks up as a super-Earth, its diameter 1.6 times ours, swelling its mass to perhaps 5 times Earth's weight. Surface gravity? A crushing 2.2 g, forces that would pin you down like an invisible giant's hand. Walking there? Forget graceful strides. Every step would be a Herculean effort, muscles straining against the pull. But oh, the hidden gifts this gravity bestows. It clutches a thick atmosphere like a jealous guardian, warding off the vacuum of space. This blanket of air, dense, protective, could shield against cosmic rays, ultraviolet blasts, and meteorite barrages that would scar lesser worlds like Mars. Swirling clouds, moderating day-night swings, trapping just enough heat to cradle liquid water, the elixir of life. And water? Ah, that's where the story turns epic. Models whisper of vast, shallow oceans, sprawling across flat terrains, unmarred by towering peaks or gaping chasms. Gravity's iron fist flattening the landscape into a serene expanse. No jagged Himalayas here. Instead, a canvas of gentle undulations, where seas merge seamlessly with land. These oceans, warmed to perfection, could pulse with an active hydrological cycle. Evaporation birthing clouds, rains nourishing the soil, rivers carving subtle paths. Water doesn't just quench thirst. It stabilizes the climate, absorbing heat like a cosmic thermostat, preventing wild swings that could doom budding life. Sunlight from Kepler-452, so akin to our sun's spectrum, would pierce these waters, fueling photosynthesis in alien depths. Imagine primordial soups bubbling with single-celled wonders, evolving over billions of years into thriving ecosystems. But hold your breath. Here comes the heart-pounding speculation. If life took root in those ancient seas, what forms might it wear today? In the shallows, photosynthetic organisms could bloom like Earth's cyanobacteria, tinting the waters in greens or blues, absorbing light wavelengths, tailored to their star. On land, gravity's tyranny would sculpt stocky, resilient beings, squat creatures with reinforced skeletons, multiple limbs splayed for balance, hearts pumping furiously against the downward drag. Flight? A daring dream. Skeptics cry impossible under such weight, wings crumpling like paper. Yet, if the atmosphere thickens like a foggy veil, lift could defy the odds. Envision colossal gliders, pterosaur-like, riding thermal updrafts with wings spanning meters, bodies hollow, yet unbreakable. These aren't mere fantasies. They're extrapolations from universal biology, energy extraction, genetic replication, natural selection, twisted by Kepler-452b's unique forge. This planet isn't a static rock. It's a living laboratory, testing life's resilience against stronger pulls, warmer glows, and deeper time spans. With 1.5 billion extra years, evolution could have birthed intelligences pondering their own stars, or ecosystems more intricate than Earth's rainforests. As we peer through telescopes, hearts racing, Kepler-452b beckons like a siren's call. Could this be the mirror where we see alternate versions of ourselves? Or a stage for life so alien it redefines existence? The answers lie shrouded in its clouds, urging us onward in this interstellar saga. You've journeyed across the stars, enchanted by Kepler-452b's siren song of shallow oceans teeming with alien life, a stable sun, nurturing evolution's wildest dreams. But now, as you draw nearer, shadows creep in. The cosmos isn't a fairy tale. It's a battlefield of extremes, where one misstep spells oblivion. Lurking beneath the planet's temperate facade is the specter of a runaway greenhouse effect, a ticking bomb fueled by that extra 10% stellar energy. Imagine oceans boiling away, steam rising like a funeral pyre, transforming this potential Eden into a Venusian nightmare. NASA's models paint a grim picture. If CO2 levels spike unchecked, temperatures could spiral to 870 degrees Fahrenheit, crushing any hope under 92 times Earth's atmospheric pressure. What starts as a warm embrace turns into a suffocating stranglehold, evaporating seas in cosmic mere millions of years. This isn't idle fear. It's a controversy raging in astrobiology circles. Optimists argue cloud cover or efficient carbon sinks could avert disaster, much like Earth's regulatory cycles. Pessimists counter with Venus as Exhibit A, a once watery world, now a molten hell. Kepler-452b teeters on this knife's edge, its fate a heated debate that challenges our models of climate resilience. Dive deeper, and the ground trembles with inner turmoil. Beneath that flattened landscape, a super-Earth's core pulses with potential fury. Radioactive elements, uranium, thorium, potassium-40, could churn out heat like an over-fired furnace, igniting relentless tectonics. Volcanic mega-eruptions spewing ash clouds that blot out the sun, earthquakes reshaping continents in cataclysmic heaves. Sure, mild geology recycles nutrients, birthing life like Earth's plate tectonics did. But excess, it's apocalyptic, turning paradise into a ash-choked wasteland. Scientists spar over this. Some simulations suggest super-Earth's thicker mantles dampen activity, fostering stability. Others warn of supervolcanism, where pent-up energy unleashes Yellowstone-scale events on steroids. Kepler-452b's higher gravity amplifies the stakes, compressing rock, intensifying pressures. Is it a cradle or a crucible? The controversy underscores our ignorance. Without direct probes, we're piecing together puzzles from distant light flickers. Then comes the invisible assassins, biological perils that could unravel everything. Suppose life thrives there, microbial hordes or complex beasts evolved in isolation. Our earthly immune systems, laughably outmatched against alien pathogens, viruses with biochemistries twisted by different amino acids or genetic codes. A single spore hitchhiking on a future probe could spark interstellar pandemics, our bodies erupting in unforeseen horrors. Flip the script, and humanity becomes the invader. Our microbes decimating native ecosystems, like European diseases, ravaged the Americas. Ethicists decry this as cosmic colonialism, fueling debates on planetary protection protocols. NASA's guidelines already quarantine Mars samples, but Kepler-452b at 1,400 light-years, it's a thought experiment turned nightmare. Critics argue such fears are overblown. Remote sensing via telescopes like JWST could sniff biosignatures without contact. Yet, the controversy rages. Should we even dream of venturing, risking mutual annihilation? These risks aren't just planetary. They're mirrors to our controversies here on Earth. Kepler-54b's discovery in 2015 sparked euphoria. But a decade later, in 2025, it's mired in skepticism, early hype, as Earth 2.0 drew backlash for oversimplification. Its ESI of 0.83 is impressive, but rivals like TOI 700D, ESI 0.93, or K272e steal the spotlight with closer proximity for study. Tidal locking dismissals irk proponents of red dwarf worlds, where habitable eyeball zones, twilight bands between day and night, could nurture life, as recent papers suggest. Gravity's no-flight edict? Debated fiercely, denser atmospheres might enable avian wonders, per exobiologists modeling buoyancy. Even the planet's super-Earth status stirs division. Is it rocky, or a mini Neptune with a gassy envelope, smothering any surface? JWST's 2023 observations of similar worlds lean toward the latter for some, casting doubt on Kepler-452b's solidity. Yet amid the storms of debate, a profound truth emerges. Kepler-452b isn't just a dot in the sky. It's a cosmic wake-up call. As we chase distant mirages, Earth stares back, fragile and irreplaceable. Our oceans acidify, forests burn, climates shift under human hubris. The search for a second home amplifies the urgency. Protect the first. Billions of exoplanets may exist, but only one cradles us, a blue marble suspended in void, its atmosphere a thin veil, against oblivion. Kepler-452b's story isn't triumph or tragedy. It's a reminder of our stewardship. In this vast, indifferent universe, humanity's odyssey outward must begin inward, cherishing the miracle beneath our feet. For if we fail here, what hope for the stars? The greatest controversy? Not the planet's habitability, but our own readiness to learn from it.